The next
This is what this is
presentation, yeah, the next presentation, I'm not sure if there are anyone from the authors there. We have Ali Golabchi, Linda Miller, Hussein Rouhani, and Mehdi Tuvakoli. I'm not sure if there are anyone among the participants here.
Can you hear me? Okay.
Yeah.
No, we don't have anyone from that paper here, but they sent us a video, so we're going to play the video.
Okay.
Hello, everyone, and thank you for attending this presentation where I discuss our work on evaluation and adoption of exoskeletons in the construction industry, including our work on evaluating them for manual material handling tasks. So here's a quick history of the exoskeletons, starting with the GE's Hardyman and then exoskeletons for healthcare and military. But since 2015, commercial industrial exoskeletons have started to be adopted more, and that is the type that we are more interested in and mostly focused on. So the adoption of industrial exoskeletons has been primarily in the manufacturing and automotive industry, mostly due to the cyclic nature of the tasks and the predictability of them as compared to construction. And some good progress has been made. For example, Toyota is requiring exoskeletons as PPE in some of its plants, and also standards are being developed that are an important piece in the adoption of the technology. But we're mostly looking into the construction industry, and there are various reasons why this technology can potentially be useful in construction. So we know that we have an aging workforce, we have a shortage of labor, and the costs of overexertion and sprain and strain type of injuries are fairly high. These statistics are for Canada, but they are fairly consistent globally. So if we have a technology that can potentially reduce the forces on a worker's body, we could definitely benefit from that in an industry like construction. But there are also challenges associated with adopting this technology in construction. Unlike manufacturing, the construction industry involves dynamic work sites where workers are engaged in a variety of activities and things are constantly changing. Also, the fact that traditionally construction is one of the industries that's slower to adopt new technologies. So all this necessitates more research and testing to evaluate the suitability of these suits for different construction tasks. So our overall goal is to evaluate the adoption of exoskeletons in construction. And that is in three main domains. One is looking at the tasks that this technology can be suitable for and how do you identify those tasks. Second is the adoption process itself. What are the things you should consider when you want to evaluate and adopt an exoskeleton? And the third is the design aspect and how exoskeletons need to be designed to be properly adopted for construction tasks. So we first started with evaluating exoskeletons for simple manual material handling tasks and started with the subjective factors really. So we wanted to know the user's perceptions on using exoskeletons for static and dynamic manual material handling tasks and compare the two and their role, what role posture has in that, and also the feedback from different genders. So we had 12 participants, 6 male and 6 female, and we defined different scenarios of dynamic and static manual material handling with and without the exoskeleton, and also freestyle postures for lifting versus bending versus squatting. So we looked at different variables, things like the rate of perceived exertion, also variables such as overall fit, and comfort of the suit, whether it limits the user's movements, and the overall effectiveness. We also asked whether the participants felt any discomfort, and if so, in which body part, and for how much was that discomfort on a scale of 1 to 10. We compared the variables for the static and dynamic scenarios, and also, as mentioned, compared the feedback from male and female in terms of the RPE, as well as the level of discomfort on different body parts, as well as the variables such as the fit, interference with other activities, and effectiveness, and how they differ between the two groups. So the details of the findings of the study and all the charts are in the paper, but here are some more general and high-level findings that might be of interest. Users generally found the exoskeleton effective, and there are no substantial difference between the effectiveness for dynamic versus static tasks, while it was found slightly less effective for squatting during static tasks. Also, the overall effectiveness and comfort level was higher in bending compared to squatting. We had some discomfort reported, especially in the chest for many of the participants, and that's because of the chest pad that existed and kind of pushes you back during the lifting. The participants rated that the exoskeleton moderately limited their movements and can potentially interfere basically with other tasks to some moderate level. Male participants experienced a higher discomfort on all body parts except on the arms, which was an interesting finding. The participants reported a slightly higher RPE in squatting compared to bending, which makes sense because the back support exoskeletons really provide the support when the back is actually bent. Male participants reported higher RPEs for all scenarios of static manual material handling, and majority of participants rated acceptable usability, while female participants found the suit slightly more effective. So again, more detailed outcomes can be found in paper, but it really showed us that you have to look at all these different factors and focus on the task at hand and the posture that's adopted for that, and the characteristics of the user to make the adoption actually effective. As a next step, we took the experience to the field and also added some objective measurements, including muscle activity, using EMGs and motion analysis using IMUs, and obviously in addition to the subjective measurements. So the task we looked at was opening manhole covers, which results in a lot of discomfort and also injuries in the lower back due to the heavy weight of these manholes. So for this experiment, we started with in-lab measurements and took the measurements to the field with actual workers as subjects. So the type of things we're looking at is how much change in muscle activity is happening in each muscle with and without the exoskeleton, and how is it impacting the posture and the different variables. So this is an ongoing research, but some of the general findings again include that while the exoskeleton helped reduce muscle activity on the lower back, it wasn't necessarily helpful with some of the tasks and postures, as extra effort was required. For example, when these were squatting, as we saw in the previous experiment. The fit was all again another big issue that came up. The chest pad again caused some discomfort on the chest area for some participants, and also some discomfort on the legs as the load is transferred from the back to the legs, especially with postures such as squatting. In some cases, the exoskeleton might limit the range of motion, but that might not be a bad thing because it might actually improve the posture in some cases. And also that the workers, they had different tools to use for this task, so we could compare the different techniques and the different tools used with the different modes of the exoskeleton, which was in this case a standard mode and an instant mode. Another important ongoing research for us is the adoption of exoskeletons for construction and the different tasks that need to be done and the different considerations and the questions that need to be asked for the evaluation and implementation of the technology. Because we found very early on that there's much more needed than purchasing exos and handing them to workers and expecting it to work. And I have talked to many people in different industries that have done that and the adoption has not been successful. So what are the actual steps? What are details of what we need to look into if we want to successfully adopt, first of all, evaluate and then adopt a technology like this? So some overall observations from our projects. The adoption should always focus on the task and should be evaluated at the task level. Exoskeletons are not a one-size-fits-all solution, and each exoskeleton is designed for certain applications, so tasks should be assessed individually. In the comparison between passive and active exoskeletons, passive ones are the way to go for construction, at least based on what's currently available, as they're lighter, cheaper, easier to maintain, and all that. Another important point is that most existing exoskeletons are not designed for construction, so more work is needed to identify the design needs and work with the vendors. For example, incorporation of other items like PPE or tool belts when using an exoskeleton is fairly important in construction. Also, a lot of research is looking at the same measurements, such as muscle activity, and usually improvements are shown, but maybe the bigger piece is the adoption challenges, from cultural factors to organizational factors to heat and comfort and things like that. And we feel like that's something that needs more attention compared to the objective measurements. Use of exoskeletons can also result in behavioral changes. For example, the postures adopted when carrying out a task. It can also reduce range of motion, but as mentioned, that's not always a bad thing because it can make it safer. We still need to benchmark how we measure effectiveness of exoskeletons and their use in construction because it's fairly new. Also, impacts of the long-term adoption is missing, again because of the new nature of the technology, and we need more studies looking into that. We also found that the cost of the exoskeletons are still high for construction. And also an important point that exoskeletons are a form of PPE and should not replace other controls higher up in the hierarchy of controls. Thank you, everyone. If you have any questions or would like to talk more about exoskeletons, I would be happy to connect, and you can reach me at my email. Thank you again, and have a great rest of your day.
Okay, thank you for showing the video.